do like 3x plus 1 times 2x minus 1 equals 0. So there are two components that we need before we can use this principle of zero products. And it says it right in the name of the principle, zero and product. So we need a zero on one side of the equation. We need a product on the other. So we want to ask ourselves, is 0 on one side?
Yes.
Yes. Is there a product on the other side? And remember that a product is just a polynomial in factored form. Like that's what it means to factor something, is to write it as a product. So to write it as several things being multiplied. In this case, the things are polynomials. But the way that we can tell is the only operation outside of parentheses is multiplication. So for everything we do in this unit, this is going to be a really important distinction, is when something is in factored form. So if it's written as a product and when it's not. Because everything we're doing is based on the idea that we've factored a polynomial and that we've written it as a product. So just like when we worked with fraction, like numerical fractions, and we did prime factorization, and like nothing that we did with prime factorization worked if what we had written wasn't a factorization, right? If we wrote 10 as 4 times 2 plus 2, like that's true, but it's not a factorization of the number 10 because I didn't write 10 as the product of other numbers. Yes? No? Sure? So being able to recognize when a polynomial is factored is going to be really important. So you'll hear me correct you if you use the word term for factor or the word factor for term. And the reason for that is that it's really important that we understand the distinction between things that are being multiplied together and things that are being added or subtracted. So in this case, is this a product? So is it factored?
Yes.
It is. And the way that I know is that when I look outside of parentheses, the only operation is multiplication. The multiplication is right there. There is no addition or subtraction. So I have two factors. Within each factor, there is more than one term. But because I have those parentheses grouping those terms, we can think of 3x plus 1 as a single number, and 2x minus 1 is like a single number. And those two things are being multiplied. So now that everything is in, or now that I have a 0 on one side and a product on the other, this is in the form I need it to be in order to use the principle of zero products. I will probably mess up and call it the zero product property more than once. It's just another name for it. I try to catch myself, but if I don't, that's why. It's all the same thing. So I have two things multiplied to give me a product of 0, which means that if 3x plus 1 equals 0, would that make this equation true?
Yes.
It would, right? I would have 0 times 2x minus 1 equals 0, which is true. Because it wouldn't matter what 2x minus 1 was. Multiplying by 0 gives me a product of 0. And if 2x minus 1 were equal to 0, would that make this equation true?
Yes.
It would. So that would give me 3x plus 1 times 0 equals 0, which is also true. So the solutions to this equation and this equation are the solutions to this equation. Notice that we're going to have more than one solution here, and that's totally fine. When we solve an equation, we're looking for every single possible x value that I can plug into that equation that will make it true. And so there could be 1, there could be 2, there could be 3, there could be 4, etc. We will find out that the degree of the polynomial tells us the largest number of solutions that it can have. So if you have a degree 2 polynomial, it will either have 0, 1, or 2 solutions. If you have a degree 3 polynomial equation, it will either have 0, 1, 2, or 3 solutions. So in this case, we have 2 solutions. Let's find them. I'm going to just rewrite this without all my commentary so you can kind of see the process from beginning to end. So I check that I have a 0 on one side and a product on the other, which we already did. And then I say, okay, that means that one of my solutions will come from this equation and one of my solutions will come from this equation. And that's pretty handy because those equations are both linear and we know how to solve linear equations. So on the left, I'm going to subtract 1 from both sides, which gives me 3x equals negative 1. And then divide both sides by 3, which gives me x equals negative 1/3. On the right side there, I'm going to add 1 to both sides. So 2x equals 1 and x equals 1/2. So the solutions to my equation are negative 1/3 and 1/2. We use those separately. It's not like you plug them both in at the same time. If we were to plug negative 1/3 in for both instances of x, it'll make this equation true. If we plug 1/2 in for both instances of x, it'll make this equation true. Because plugging negative 1/3 in will make this guy 0, so it doesn't matter what it makes the other factor, and vice versa. So our general idea here is to get a 0 on one side, a factored polynomial on the other, and then we're going to set each of our factors equal to 0. So let's write that down. We're going to get 0 on one side of the equation. And we'll always do this using addition and subtraction. So we're just adding or subtracting all of the terms that are on one side of the equation from both sides so that all that's left there is 0. Next, we are going to factor the other side of the equation. So these first 2 steps in this last example were already done for us, right? We already had a 0 on one side and that left side was already factored. So we didn't have to do any of that. We just checked that they were both true. And then the last step is to set each factor equal to 0 and solve each resulting equation. So the idea here is just that we take these polynomial equations and we write them as the product of linear factors so that we can break them up into several linear equations that we know how to solve. So just by isolating x. So let's do a few more. Okay, so first things first, do I have a 0 on one side?
Yes.
Yes. I know it seems a little silly, like it's kind of obvious that we have a 0 on one side, but slowing down to actually check for these things is going to help you not like rush into a mistake. Do I have a product on the other side?
Yeah.
That is multiplication, right? I look to make sure that there is no addition or subtraction outside those parentheses. And so I'm going to set each factor equal to 0. How many factors are there on the left side of that equation? How many things are being multiplied?
2.
3.
Yes and yes. So,
That helps.
well, I'll explain. So there are 3 factors here. The factors are 4, x, and x plus 2. So I just set all 3 of my factors equal to 0, right? Those are the 3 things that are being multiplied here. We can think of this as 4 times x plus 2. But notice this equation is just simply not true, right? A constant is never going to be equal to 0. And so we could instead, if we wanted to, think of this instead as for x equals 0 and x plus 2 equals 0, and we would get the same result. So that's why you're like sort of both right. There are 2 factors that give me solutions, although technically we have 3 things being multiplied. But when one of your factors is a constant, it doesn't contribute a solution. Only the variable factors contribute a solution to your equation. Does that make sense? So you can kind of look at it either way. This just gives us x equals 0, right? Because the only thing you can multiply by 4 to get 0 is 0. And then this guy gives me x equals -2. In my math lab, you will write it this way. It'll ask you to list your solutions separated by commas. Notice there are no parentheses here. That seems like a really small detail, and it seems like we're really picky if we mark you wrong for putting parentheses. But remember back when we were graphing equations like x plus y equals 5, that the solutions to those equations looked like this. This was an x, and this was a y. And that ordered pair was one solution to the equation. Like, to something like that. Whereas these are 2 separate solutions. They're both x values. One of them's not x and the other one being y, right? We have 2 separate solutions to a single equation, whereas an ordered pair is one solution to an equation that happens to have two variables. And so it seems like a really, really small distinction because visually they look very similar, but it makes a big difference as far as mathematically what we're saying, if we're giving an x and a y value or if we're just listing several x values. Does that make sense? Hello?
Yes.
Anybody home? Okay. Okay, here, you guys try this one.
So why don't you multiply that then? Because technically shouldn't it be 4x squared and then 8x?
But then it wouldn't be factored. So let's look at it. Let's look at if I did this, 4x squared plus 8x, that's the simplified version of this polynomial, which is not more correct or incorrect than a factored form of the polynomial. It just depends on what you're using it for. How could we solve that for x?
2 or x plus 2x, or 2 plus minus and plus on 2x parentheses and then 4x and 4x and then reduce them down to 2x and 2x.
Are you factoring?
Yes.
Yes. We solve by factoring, which is already done over here. So the only way, like there's no way when we have an x squared component and an x component, there's just no way to isolate x. Like you can't get x by itself by adding and subtracting and multiplying and dividing, because when we solve for x, we have to somehow end up with a single factor of x on one side, and that can't be done if I have an x squared and an x. So the only way for us to actually solve these guys is to somehow write it in such a way that we can split up those factors so there's just a single x in each one.
So then the 0 basically tells you not to do the multiplication of the parentheses and the...
So the fact that this is a nonlinear equation tells me that I want it factored on one side. And it's a little hard to see that it's not linear in this, like when I give it to you in factored form already, just because there's no exponents, right? But if there's a 0 on one side and the other side is factored, like, you're just like, oh, I'm going to set each factor to 0. Like, there's no need to distribute and be like, oh, wait, this isn't linear, and then factor again. Like, if it's already factored, you can just use that principle of zero products immediately. Just in time for you guys to try one. Actually, do these two, so, and then we'll get to the more complex ones. So just 5. No, that didn't work. So all of the examples that we've done so far have already been in factored form. So we've started with a 0 on one side and a product on the other. So we've gotten to like basically skip the first 2 steps. We just have to verify that they're true, and then we skip right to the 3rd step. So that won't always be the case. In fact, it's usually not, because usually when we're given a polynomial, it's not in factored form, like we have to factor it to get there. Usually polynomials are presented in standard form or general form, which means that they're simplified rather than factored. So let's solve try to make make it legible. Why can't I make a 2? 2, there we go. Equals 9x. Okay, so let's look at our 3 steps. Do I have a 0 on one side?
No.
I do not. So how might I get a 0 on one side?
By subtracting 9x.
Mm-hmm. And you could either subtract 9x from both sides to get a 0 on the right, or you could subtract subtract 3x squared from both sides to get a 0 on the left. I would choose always to do the subtraction in such a way that the term with the highest degree has a positive coefficient. Remember that when we factor, we always want that first term to have a positive coefficient. So if I were to subtract 3x squared from both sides, I'd have a negative 3x squared, and I'd have to factor that into my factoring. And so just to simplify your life a little and avoid a bunch of negatives floating around, if possible, you should always try to keep that largest degree term positive. So if I subtract 9x from both sides, I've got 3x squared minus 9x equals 0. So we just took care of that first step. We got a 0 on one side. Now, is the left side a product?
No.
It is not, right? This is a polynomial in simplified form. It's the sum and or difference of individual terms. So we're going to factor this. So my GCF here is 3x. So I get 3x times x minus 3 equals 0.
You don't factor to the normal way you do a binomial?
I do factor it the normal way, which is always to factor out the GCF first. So now we're right back in the situation we were in the previous problems where we have our 0 on one side and a factored polynomial on the other. So I can say 3x equals 0 and x minus 3 equals 0, which gives me x equals 0 and x equals 3. Questions? Okay, so don't write this down. Why not? I want everybody to look at it long enough to decide for themselves why that is totally not legitimate. What makes that different than what we did over here? There's no 0. And why does that matter?
Because that's the rules that we have to have a 0 on one side.
But why? Like, why doesn't it work for 1?
Because it's an odd number.
Because the whole thing is equal to 1, not when you split it up.
Right. So there's something kind of special about 0, right? Which is that when you multiply it by something, it doesn't matter what you multiply it by, you will get what? 0. If you multiply 1 by something, will you always get 1?
No.
If you multiply 2 by something, will you always get 2? 0 is the only number that no matter what you multiply it by, you will get 0 back. Which is why we can say that if several factors are being multiplied to get a product of 0, at least one of them has to be 0. And really, any of them can be 0 and it'll make it true. That's not true of any other number. Like, if I make 3x equal to 1, whether or not the product is 1 is entirely reliant on what x minus 3 turns out to be, right? I can't just multiply 1 by 5 billion and get 1 back. But I can multiply 0 by 5 billion and get 0 back. And so this principle of 0 products is totally based on the fact that our product is equal to 0, because 0 is the only number that you can multiply by any other number and still get a product of 0. So that if I make my solution 3, it doesn't make all of those factors all of those factors 0, but the fact that it makes one factor equal to 0 means that my product will be 0. And so it doesn't matter what it makes the other factors. It's still a solution. Whereas making one of my factors equal to 1 over here isn't going to make the product equal to 1. In fact, even if x and x minus 3 were equal to 1, I'd get 3 when I multiply by 3, right? And so it looks really similar to what we did, but because the properties of 0 are so unique, that's why this process only works if I have a product equal to 0. And so that's why our very first step always has to be to get a 0 on one side. So nobody wrote that down, right?
Get a 0 on one side.
No, the thing I just wrote, because I don't want you to like accidentally think that's an example of something that does work. Okay, let's do some more. Okay, you guys tell me what to do.
We need to vector.
Good. So we verified we have 0 on one side, and then we'll factor the other side. The way that we factor has not changed even a tiny bit. Everything we did last week. So there's no GCF. My AC is 6. My B is 5. And so my numbers are 2 and 3, because they both need to be positive, because AC is positive. So I've got x squared plus 2x plus 3x plus 6 equals 0. Factor out my x. Factor out a 3. And we get x plus 2 times x plus 3 equals 0. Notice that every single step was an equation. I cannot tell you how many times people lose this equals 0 and then forget that they were solving an equation when they get their left side factored. Make sure every step is an equation so that you keep in mind what your final goal is through every step. So now we're going to set each factor equal to 0. So x plus 2 equals 0. And x plus 3 equals 0. Which means that x equals -2 or x equals -3. So far, so good? Let's solve It was very silly of me to put this at the bottom of this page. There we go. Now we've got room. You guys tell me what to do.
Get 0 on one side.
How?
Or add 2.
Yeah, we'll add 2 to both sides. Now what?
We need to factor so we only have multiplication on one side.
Very good. So notice, guys, that this is not a product. Remember when I showed you guys earlier, like how like we could write 10 as 4 times 2 plus 2, but that's not, it's prime factorization, right? In fact, it's not a factorization at all because it's not a product of numbers being multiplied together. So even though it's true, it can't be used to do any of these problems that rely on multiplication as their basis. So the left side is not a product. I want it to be a product. What should I do first to achieve that?
I don't know.
Any ideas?
Add to each one.
So I like that idea. I need to be able to add 2, right? But remember, in polynomials, to add, we have to combine like terms, right? So what would I have to do here in order to be able to combine like terms?
Take it as a parenthesis.
Yeah, I have to get rid of those parentheses, right? I'm going to have to simplify this before I can factor it, because there's no way I can incorporate that 2 in unless I write this whole thing as a bunch of terms being added together. And so we're going to distribute. And now I can combine like terms. So 3x squared minus 17x plus 24 equals 0. And now we're going to factor. So AC is 72. B is negative 17. This looks a little bit worse than it is. I think if you stare at it for a minute, you'll probably be able to like come up with the numbers without making a huge list.
Eight, negative 9.
Yeah. Because they both have to be negative. So negative 8 and negative 9. You could, of course, have made the whole list if you didn't see that. But some of them like this, like we kind of just know 17 and 72. I don't know. When I look at 17 and 72, I think of 8 and 9, kind of both ways. So we've got 3x squared minus 9x minus 8x plus 24 equals 0. Factor a 3x out of our first group, and get x minus 3, and factor negative 8 out of our second group and get x minus 3. And so x minus 3 times 3x minus 8 equals 0. There are some ways to factor more quickly, which I don't want to show you guys just yet because I don't want to confuse you with too much all at once. But once we get kind of comfortable with the things that we're going to do with factoring, and you guys get really good at doing it the long way, I can show you sort of some quicker ways to do it, which they're not different ways of doing it. They're just ways of like manipulating this same information in a different way, so you don't have to write quite as much. So it's not like there's a different like method to it. It's just there's like just some shortcuts you can do to avoid having to write as much out. But I don't want to overwhelm you with too much random stuff right now. So now we're going to set each factor equal to 0. So x minus 3 equals 0, and 3x minus 8 equals 0. So add 3 to both sides, we get x equals 3, and 3x equals 8. Divide both sides by 3, and we get 8/3. Remember at the beginning of class, you guys asked, like, you know, like, if you can write the plus 3 underneath and the whole thing, and I said that's fine, but these problems are going to get longer and have more steps to them, so if you can, like, get comfortable with doing some of that, like, in your head rather than writing it, it's going to cut down on the things you have to write. So this is kind of the type of thing I was talking about, is just that there's already so many steps that once we get to the end here, like, if you can add 3 to both sides without actually writing plus 3, you're just cutting down on like what you have to, how much you have to do. But of course, don't skip to anything before you're comfortable with it. How do you guys feel about this?
Okay.
Do you want to do more of them? Let's solve this is a good one. 8x to the 4th minus 6x to the 3rd equals 9x squared. What should I do?
Move to 9x.
So we will,
Negative 9x.
yep, subtract 9x from both sides.
Does it matter where you put it, or you always want to put it on the end?
So in anticipation of factoring, we're going to place it in such a way that it's in descending order.
Descending order, yeah.
Yeah. So like if the 6x to the 3rd had been on the other side, I would have placed it in the middle so it was in the same order. And what should I do next?
Factor.
Okay, perfect. What's the first step to factoring that?
GCF,
Yes.
which would be 2. Oh, 3.
Or x squared.
Yep, just x squared. So 8, 6, and 9 don't have any common factors, but I do see that there's variables in all of my terms. So that's something you can look for as far as like knowing if there's a variable GCF is we get 8x squared minus 6x minus 9. And so then we want to factor what's in parentheses there. So my AC is negative 72. My B is negative 6. Because AC is negative 72, I need a positive and a negative.
So negative 12 and 6.
Good. So we have x squared times 8x squared minus 12x plus 6x minus 9 equals 0. And then x squared, let's see, 4x and a 3. And we are almost done factoring. 2x minus 3, 4x plus 3 equals 0. And now I want to set each factor equal to 0. So in this case, I have more than 2 factors, right? We've had 2 factors for most of the ones we've done so far. Here I've got x squared, 2x minus 3, and 4x plus 3. All 3 of those factors contain a variable, so I have to set each of them equal to 0 separately. So x squared equals 0. 2x minus 3 equals 0, and 4x plus 3 equals 0. If x squared is equal to 0, what does x have to be?
-1.
So let's write it another way. Remember that x squared is just x times x, right? So I have 2 factors there that are being multiplied to get 0. So one of those factors has to be 0, right? So 0 times 0 is 0. So if you have any power of x equal to 0, then x is just 0. Like I could have x to the 10th equals 0, and x would have to be 0 because it's just this big row of factors that are all the same. So if one of those factors is 0, they're all 0. And then 2x equals 3, and x equals 3 halves, and 4x equals negative 3, which gives me x equals negative 3/4. If you don't like that, the other thing you could do is write this as x times x up here, and then set 1, 2, 3, 4 factors equal to 0. But 2 of those are going to give you the same thing, right? You're going to have x equals 0 and x equals 0 from those first 2. So it's a little simpler just to recognize that if something squared is equal to 0, then that thing has to be 0 itself.
So with these,
Mm-hmm.
when we have 0 on the end,
Mm-hmm.
with our A, C, and B, is that ever going to end up being prime?
Great question. So yes, but not for a couple weeks when we learn the other ways that you can solve a quadratic. So if the polynomial is prime, it doesn't necessarily mean the equation doesn't have a solution, but it does mean that we can't solve it by factoring. So for now, no, none of them will be prime because if I give you one to solve, I want you to be able to solve it. But in a couple weeks, the very last chapter that we do is on other ways of solving quadratic equations, like if you can't factor them.
Okay.
So for now, all of the ones you encounter should be factorable. So if you find one that's not, go back and recheck your A and your C and your signs and all that stuff. Okay, you guys try this one. Oh, that's aggressive. I can go through how I got that if somebody didn't get it. I think that walking around it looked like everybody did. Yeah? When we factored. And so we set each factor equal to 0. and we get x equals 0, x equals 4, x equals 4. How many solutions does this equation have?
It's 2, right?
Well, because 4 is a solution, right? Like, so this is, remember I said that the degree of the polynomial is like the maximum number of solutions that an equation can have. So the reason that it can have less than that degree is that some of them can be repeated. In fact, in this equation, both of them are repeated. Like x squared equals 0 gives us x equals 0 and x equals 0, right? But we just write it once, because once a number is a solution, like writing it twice doesn't give us an additional solution, right? Plugging 4 in makes the equation true, whether I say you can plug 4 in once or you can plug 4 in twice. So the solutions are x equals 0 and 4. If you didn't write this, like if you just wrote that, that's fine. I'm not going to like knock you down for like writing 4 twice. I just wanted to point out that having more than one factor that leads to the same solution doesn't actually give us more solutions. It just gives us the same one multiple times. So we don't have to, when you're giving your answer, you don't have to list it more than once. I don't know that I've ever seen anybody do this, but I would venture to guess that if you put this into my math lab, it would tell you you were wrong. But I don't know. Nobody's ever, or maybe it doesn't tell you you're wrong because maybe people have done it and it hasn't caused a problem, and so they haven't asked me about it. But I've never had anybody encounter that issue. So I don't know if it's that nobody did it or that it's okay. But I guess you guys will find out tonight if you do it. Okay, so at this point, I'm going to give you your homework, and I want you to work on it for about 20 minutes until like 10 after, just so you can get some practice with solving these guys. There's one more small topic, like extension of this, that we're doing today, but I want you to like practice the basic solving for a little bit first before I throw anything else at you.
So we can't do the hard one even first?
No, you can. The other thing isn't on the homework. Or not on the written homework, at least. Just to remember that equals 0. And then a few of you asked me, what was it? Was it x plus 9, x minus 6, number 5? So a few of you asked me about that 2, right? So that 2 is a separate factor. We could set it equal to 0, like we do with our other factors. Oops. But most of you kind of noticed on your own that that's just never true, right? So if your GCF doesn't have a variable in it, it's not going to contribute a solution to the equation. So you could just not write it, or you can write it every time just so you're making sure. But this just doesn't give you that factor just doesn't give a solution to the equation. So the other two are the only ones that do. Okay, so the last thing we want to look at here is how this relates back to graphing, because that's, like in 121 in calculus, like that's where we use this most often is, really, calculus is just the study of the behavior of equations in two variables, so the behavior of graphs. And so we're kind of, everything we're doing is kind of leading up to relating everything back to that. So we're going to look at this equation. So I gave you the graph of the equation, and just like when we did linear equations, to find this graph, you could just pick a whole bunch of numbers for x, plug them into the equation, and get numbers for y. It just gives you a bunch of ordered pairs, and it turns out that the ordered pairs don't make a straight line. In this case, for quadratic equations, they make what we call a parabola. So it's either a smile or a frown, depending on which way it opens. But at this point, I'm not going to have you graph them. What I do want to do is find the x-intercepts. So we intentionally did not label the graph because we want you to find the x-intercepts algebraically. So what do we know about points that are on the x-axis? So remember that points are ordered pairs. They have an x value and a y value. Remember back to when we found intercepts of linear equations. How did we find those intercepts? What can you tell me about these 2 points? Yeah, the y-coordinate of any point on the x-axis is going to be 0, right? Because if you're on the x-axis, you haven't gone above or below. So the process of finding intercepts doesn't change based on the type of equation or the type of graph. No matter what type of equation we're working with, whether it's linear, quadratic, or one of the many other equations we're going to look at, to find the x-intercepts of the graph, you always set the y value equal to 0. Because setting the y value equal to 0 means that it's a point on the x-axis, which is exactly what it means to be the x-intercept. So to find those x-intercepts, I'm going to just replace y with 0. So 0 is equal to x squared minus 4x minus 5. Can we solve that equation?
Yeah, can you flip it around?
Oh, you want to write it the other way? Sure.
No, I mean, you don't have to write it. I'm just asking if you can
Uh-huh.
flip it around. Because it's kind of like doing it backwards that way.
Uh-huh. Yeah, if 2 things are equal, they're either equal in either way.
Yeah.
So yeah, I'm more comfortable with it written the second way as well. It just looks a little bit more
Yeah,
familiar.
you can solve that.
So what should I do?
Can you get your AC?
Mm-hmm. So we're going to factor the left side, right? AC equals -5, B equals -4. So -5 and 1.
That's crazy.
X minus 5 plus, so we have x minus 5 times x plus 1 equals 0. And so x minus 5 equals 0, x plus 1 equals 0, x equals 5, and x equals -1. So what are my x-intercepts?
-1.
How should I write them?
Biggest number first. It's always a positive number and then a
As an
negative.
ordered pair.
Yeah, so x-intercepts are points on a graph, right? So we have to write them as an ordered pair. So I have 2 separate ordered pairs. 5, 0, and -1, 0. So what I just found were the coordinates of those 2 red dots. Even though the graph's not labeled, because I solved the equation, I know that that's what those points are. So remember that when you're asked to find the x-intercepts, that your answers should be ordered pairs. It can be really frustrating to get the whole thing correct and then just enter it incorrectly and like not understand why it was incorrect. So you want to be really careful that if the question is asking for x-intercepts, that you're giving ordered pairs. Now there's another type of question that they give that looks really similar to this, which is this one. So let's talk about the differences between the problems first, and then we'll do that second problem. So here, notice that they give you an equation that has two variables in it, and they say this is the graph of that entire equation, and you're going to put a 0 in for y to find two specific points on the graph. So we are doing the algebra to find information about that graph. On this one, they give us just an equation to solve, but they say use the information from the graph to solve it. So I'm going to say these 2 points are 3, 0 and -1, 0. What that tells me is that if I put -1 into this side of the equation, I will get what here? 0, which means -1 is a solution to this equation. Because if you put -1 in for x, it gives you 0. That's what the graph tells us.
-1 and 3 solutions,
Right, yeah. We do the same thing with 3. But do you guys see how we can use the graph to get the solution to the equation, just like we could use the equation to get the x-intercepts of the graph? So the solutions to this equation are what?
-1 and 3.
So in one of these problems, we're using the graph to solve an equation, whereas in the other one, we are solving an equation to find information about the graph. So I just wanted to point out that difference and the difference in what your answers look like, so that you don't get frustrated about like how you should enter the answers to them. So pay close attention to if they're asking for the points on the graph or if they're asking for solutions to an equation.
So it'll always be x-intercepts.
Yeah, they'll just say what are the x-intercepts. We could find the y-intercepts also. We'd put 0 in for x, but we wouldn't end up solving an equation, so it's not quite as interesting. So this kind of relates back to what we talked about a little bit earlier about notation, right? This is 2 solutions to an equation containing 2 variables. Right? Each solution, each of those ordered pairs gives me an x value and a y value. So one solution to y equals x squared minus 4x minus 5 is x equals 5 and y equals 0. Another solution to that equation is x equals -1 and y equals 0. So when we have an equation with 2 variables in it, the solutions have to have 2 numbers. This is 2 solutions to an equation with 1 variable. Right? This equation right here only contains an x. And so my solutions are all x values. Whereas this equation contains both an x and a y, and that's why my solutions are ordered pairs. They give an x and a y value. It's subtle, but do you guys see the difference? Okay. And a lot of it is, at this point, just a notation thing. As you keep going, it'll become even more and more important as far as like mathematically what's going on. But for the purposes of these problems, at this point, it's kind of just a notation thing that you're giving points on a graph as opposed to just x values. Any questions on this? Yes, of course. So did everybody write those down? It's nice, or you could even take a picture of them if you wanted to. It's just nice to have them in your notes so that when you get to those questions on the homework, like you know what the answers should look like. There's the other one. Okay. Any questions? We have 5 minutes, but I'm happy for us to like go early if you. But I don't want to cheat you out of 5 minutes either. So if you guys have anything else you want to talk about,